Morning, Algebra 1. This is Mrs. Latham, and we are going to be looking at some review from before we were out of school. So we're going to be looking at parallel and perpendicular lines, which is section 5.6. So if you remember, we talked about parallel lines. And they are going to be two lines in the same coordinate plane that never intersect. So what I want you to notice is in the first diagram on the left, we have two lines that have a positive slope. And if we find the slope of the first line, if we pick this point and this point, what I want you to notice is we are going up 2 and right 3. So the slope of our purple line is 2/3. If I take my slope here and I bring it down onto my purpley pink line, if you notice, it's the same. So this slope is actually also 2/3, meaning that they are parallel. They have the same slope. What I want you to notice for the diagram on the right is that we have two vertical lines. So if we actually try to find the slope of a vertical line, so say I picked two separate points here, and so this bottom point is -3, -2, and the top point is -3, 3, and say I wanted to find my slope. We're going to do y2 minus y1 divided by x2 minus x1. So what ends up happening is -2 minus 3 is -5, and -3 minus a -3 gives us 0. So if you remember my little trick, if we have 0 divided by a number, it's okay to do, that equals 0. But if we have a number divided by 0, that is not okay, and we get undefined. So this slope here is undefined, and that's true for every vertical line. So if our green line is undefined, and then our blue line is also a vertical line, then this is also going to be undefined, making them parallel vertical lines. So if we are looking at the first two questions, it says state whether or not the following pairs of equations are parallel to each other. So the idea is we have to find the slope of each line. So looking at the first one, I have x. And the number that's always going to be in front of x is a 1. So our slope for the first one is 1. If I'm looking at the second equation, I have -x. So our slope will be -1. And we know for a fact that 1 does not equal -1. And therefore, this is not parallel. Looking at the second one, notice I have -2/3 as my slope for the first equation. And then I also have -2/3 as the slope for the second equation. And since -2/3 is equal to -2/3, they're the same number, we can say that these are parallel. Another type of question that you are definitely going to be asked is finding a line that is parallel to another line. So in this question, we have our starting line, which is the equation in blue right here. And we want to find a line that is parallel to it going through the point in purple. So the first thing that we have to figure out is what is the slope? So to find out what our slope is, that's where we go back into the equation that we're given. So we have y is equal to 2/3 x minus 1. So in that equation, our slope is 2/3. And that's the slope we're going to use to find the new parallel line. So then the second question we have to figure out then is, what is the equation of the new line? So this question is specifically asking for the equation. Let's change the size of that highlighter. In slope-intercept form. But sometimes it's easier if we start out using point-slope form to write the equation and then convert it into slope-intercept form. So if I take my point and my new slope and plug it into point-slope form, we are going to get y minus 5 is equal to 2/3 times x minus 12. And that is our point slope form. But we need it in slope intercept form. So we are going to distribute. That's the first step. And we are going to have y minus 5 is equal to 2/3 times x gives us 2/3 x. 2/3 times negative 12. I will do this piece off to the side. So 2/3 times negative 12. We have to rewrite negative 12 as a fraction over 1 and then multiply across. So 2 times negative 12 is negative 24. 3 times 1 is 3, and we can reduce this to get negative 8. So I am going to put minus 8 down below. The last step we need to do is move the 5 onto the same side as the 8. So y is by itself. So we add 5 to both sides. The 5's on the left cancel, and we get y is equal to 2/3 x and then minus 3. And this is our final answer. This is the equation of the line that is parallel to our original line through the point 12, 5. So this content here isn't completely new. I taught this to both Algebra 1 sections before we left for our break. But what I didn't teach to every single class is perpendicular lines. So that's what I want to look at a little bit as well. So perpendicular lines are kind of opposite of parallel lines. So they're two lines in the coordinate plane, just as before, but instead of having the same slope, they're going to have different slopes. And what's really key about perpendicular lines is that they are intersecting at a 90-degree angle. So if we're looking at the diagrams I have, there is a 90-degree angle with the purple and pink line, and there's a 90-degree angle with the green and blue line. So the reason why perpendicular lines are so special is because their slopes are called opposite reciprocals. Now, we've talked about reciprocals in class before when we were solving equations with fractions. So an opposite reciprocal is very similar, except the only difference is the word opposite. Opposite means that if you have a positive number, we want to make it its opposite, which would be negative. And then vice versa. If you have a negative number, you want to make it positive. So if we're looking at a -2, we want to find a number that when we multiply it, we get -1. And so what we could do is we could multiply -2 by 1/2. that is the opposite reciprocal of negative 2. And what ends up happening is if we multiply across, we get negative 2 over 2, and that reduces to negative 1. So for a fact, okay, 1/2 is the opposite reciprocal of negative 2. Now, for 1/4, I will rewrite that. So for 1/4, the opposite reciprocal of this would be a negative 4 over 1. So if you notice, we are just flipping our fraction. So again, if I multiply across, I get negative 4 over 4, which is equal to negative 1. Therefore, let's pick a different color. Negative 1/4 is my opposite reciprocal of 1/4. And then for 1's kind of a special number. All we have to do is multiply it by its opposite. So the opposite would be negative 1, and if we multiply them, we get negative 1. So in this case, negative 1 is the opposite reciprocal. So, if we're given two equations, I will rewrite them for you all. So the first equation is y is equal to 3/4 x plus 7, and the second equation is 4x minus 3y is equal to 9. The question's asking, are they parallel, perpendicular, or neither? So for us to figure out what they are, we actually have to go ahead and find their slopes. So it's quite easy. Looking at the first one, the slope is the number in front of x. So our slope here is 3/4. But the question is, what is the slope of the other line? So to be able to figure that out, we actually have to rewrite 4x minus 3y equals 9 as slope-intercept form. So first thing we need to move is the 4, which we're going to subtract. The left side will cancel, and we're left with negative 3y is equal to negative 4x plus 9. The last thing we need to do for this is then we have to divide every single number by negative 3. The ones on the left cancel, so we're left with y. Then we have negative 4 divided by negative 3, which gives us 4/3 x. And then 9 divided by negative 3 gives us negative 3. So if I'm looking at this equation, then my m value is going to be 4/3. So now we have to compare these. So the first thing that we want to do is check if they are parallel. So if I do that, I would set these two equal to each other. And we know for a fact that 3/4 and 4/3 are not the same answer, so they are not parallel. So it's not parallel. To check if it's perpendicular, we have to see if they are opposite reciprocals. So we want to multiply. If I do 3/4 times 4/3, we get 12 over 12, which is equal to 1. Since we did not get an answer of negative 1 when we multiplied the two slopes, they are not opposite reciprocals and therefore not perpendicular. So that means the only option we have left is the word neither. And this is our answer. They are not parallel and they are not perpendicular. And then the last thing I want to look at with you guys is finding the equation of a line that is perpendicular. So similar to what we were doing with parallel lines, except instead of finding the slope that's parallel, we have to find the slope that's perpendicular. So let's do that first. So we want to find the perpendicular slope. So looking at the equation given, our slope is 1/3. And if I want to find the opposite reciprocal of that, I am going to flip my fraction and make the number negative. So my perpendicular slope is -3/1, or just -3. The second step is the same exact thing that we did before with parallel lines. We want to plug in our point and slope into point slope form. So I'm going to have y minus 4, remember this is my y value, this is my x, is equal to -3 times x minus 2. We are going to distribute. So y minus 4 comes down, that doesn't change. -3 times x equals -3x. -3 minus 2, or times -2, is a +6. And the only other thing we have to do for this is move the 4. So I'm going to add 4 to both sides. It cancels, and y is equal to -3x plus 10. And that is our final answer. If you guys have any questions on this mini lesson on parallel and perpendicular lines, I'm pretty much available Monday through Friday from 8 to 12. If you would like to set up a conference, we can do so over Google Meets. I plan to have a spreadsheet posted for you all. And I hope you guys have a wonderful